Hello everyone, welcome to the course on artificial intelligence in industrial and management engineering. I am Dr. Prabal and today we will continue from our previous lecture where we are trying to understand the complete overview of the machine learning process, and we have understood what are the different steps of each machine learning process, and we have also introduced you to the diamonds data set. Today we will try to create a simple machine learning model with linear regression supervised learning in the utilizing the Python ecosystem. Okay. So, let us first introduce you to the theory of the linear regression models. Okay. So, linear regression is fundamentally these LR models finds linear relationship between target and input features. So, our assumption is that the target variable and the input features have a linear relationship. So, that is why we are using these kind of models. Now, a basic equation of linear models could be y is equal to mx plus c, but today let us try to denote this equation utilizing vector form. So, vector form is y is equal to x w plus b. Here y is a vector of actual targets. So, for our diamonds data set, it is the price of the diamond. Now, x is the matrix of all feature columns. Now, a matrix has rows as well as columns, whereas vector will have only columns, right? So, what are the what rows represent and what columns represent in this x is important. So, each row is a data point and each column is a feature, right? Now, with data point, what we mean is that each row in the diamonds data set will give you the information of a particular diamond with particular features, whereas each column is a complete distinct feature in the data set. Okay. Now, W is also a vector, and these are the weights of the model, weights that the model learns while training the LR model. Okay. Now, each W is associated with a feature. So, this is nothing but, if we rewrite this, W is an influence on the target So, to understand this better, there is one more term, that is this b, which is known as bias, and this is nothing but predicted value of y when all features are absent or they have a zero value in the model. So when x is 0, then y when x is 0, then y is equal to c or y is equal to b here. Okay. So to understand this better, we can also associate our matrix calculation to understand how this vector equation works. So let's say we have 10 rows and 5 columns in a data set. Okay. So our y will have 5 comma 1 vector, x will have, x is feature matrix, so it will have matrix of all feature columns, right? So the rows have 10, means we have 10 data points and we have 5 columns. So here we have 10 comma 5 matrix, and w, since each w, which is each weight is associated with a feature, so we need to have 5 comma 1 row vector. Okay. And b is nothing but we can directly get it, like b will be 10 comma 1 row vector. So this y will be 10 comma 1. Why? Because y is the output of each row, means the target variable of each row. So what happens is, for each row we will have a target response, right? So that is what, since we have 10 rows, we have 10 data points, so we will have 10 output values. So if you now write this again as y 10 comma 1 is equal to the x vector x matrix x 10 comma 5 with the matrix product with w of 5 comma 1 plus b with 5 comma 1. So now you can easily see the matrix product will, from the right hand side, will lead to 10 comma 1. Okay. So this is a valid equation of the vector form of linear regression. Now the goal here is to minimize the error. Which error? The error between predicted values of y and the actual values of y. Okay. And to reduce this error, or to achieve this goal, we need to optimize w and b such that the error gets reduced. Okay. And to evaluate these kinds of errors, we can use sum of squared errors, or there are many different matrices. This is just one example. This is also popularly known as SSE. Okay. Or we can utilize mean squared error here. Now how does this optimization process works? So this since we are using Python ecosystem and we will implement this whole system in scikit-learn library, so the sklearn library uses normal equation to get the trained weights. Okay. And the normal equation, as we all know, can be written like w is equal to x transpose x. So this is the inverse of this multiplication with x transpose y. So our machine learning model, when we try to do it computationally, we will utilize this normal equation, and when the data set gets computationally infeasible to utilize this equation, then the model usually use gradient descent method to find the optimal weights of this process. Now let's jump into our development environment. So I have created a directory with the name code, and there are two files in it. So the first is the Jupyter notebook file. The type of this file is Jupyter source file, and another is your data diamonds, right? So it contains only a CSV of the different information regarding all the diamond related information that we have just studied. Now to start performing machine learning, you first need to install Python. So you can first write terminal, or you can open terminal by clicking right in the empty space and just click on open in terminal. Now a terminal window will open. We are utilizing this in Windows 10. So the process in different versions of Windows remain the same. You just need to install this Windows terminal from the Microsoft Store first. Now if you write here Python minus minus version, okay, so you need to open a terminal in this directory. So just right click in the empty space and click on open in terminal, and by default it will open in PowerShell. You can choose here by clicking on this drop down terminal and choose command prompt, right? And if you have successfully installed your Python from internet, then what you will get here is, if you write this command Python version, then it will show you the actual version that is being installed in on this machine, right? So you can open your browser and write this Python download, and from the official sources you can install Python in your system. Our TAs in the course will also introduce you to all the installation steps. If you want, you can just write a query in the forum. Further, I suggest you to also download VS Code, which is Visual Studio Code. This is a software from Microsoft. You can utilize any of these installer to install this, and after installing both of these, you can just type this command again and try to see whether your Python is visible to your system. Okay, now we are in this directory. We need to open our own directory here. Okay, so now we have opened this directory, and it is showing the complete address. Okay, so inside this folder we have a code directory that I have created for this demonstration. Now first we need to create an environment. So this is a Python environment, and we have already introduced all these installation and other what are different kinds of environments, how modules works in different course. You can refer to this that course. So I am writing the command for creating a new Python environment with the command Python -m vn. So this command will create Python environment with this name, that is AIMME_env. This vn is a module that we are utilizing from the Python standard libraries to create this environment. So it has created this new environment, and you can see in your file explorer that a new folder has been created, and it contains everything for running your own Python libraries. So every new library that you will install will be reported here, will be stored here, and these are the different scripts. We will utilize activate script to activate this environment. So to do that, we will write the code. Next, we will install few libraries like pip install numpy, pandas, cbon. So this command will go to the internet, find all the dependencies of these libraries and try to install it as fast as your system allows. Okay. So till now we have installed 3 libraries, that is NumPy for numerical computations, Pandas for your data frame operations, and Seaborn for your data visualizations. So you may have seen here that during the installation of Seaborn, matplotlib gets automatically installed, but you can also write this again, like we will install matplotlib and Jupyter for your notebooks and scikit-learn. This is for your machine learning models. So once all your libraries get installed, you are ready to conduct a basic machine learning project in your code directory. Okay. So just clearing the terminal and we can write Jupyter lab. So this Jupyter notebook will start inside this code directory. So this is the base directory for all the files that you will write or all the exports you will do. Okay. So by just writing this command, it will open a web browser with the Jupyter user interface. Now on the right hand side, you will get a launcher where you can either launch a new notebook with the Python 3 kernel, or you can open a new console, or you can open a new terminal, or you can also create a new text file or markdown file or any other. You can also get some contextual help. Now if you are creating a new Python notebook or any text file or markdown file, where it will get created? It will get created inside your this directory. So here your new text file will appear just below your this file, right? So everything is directly one-to-one mapping with your file explorer. So without opening any other thing, you can just open this environment and it will serve you everything. So here I have a pre-defined complete linear regression process, which I will show you how to perform. So I will walk you through step by step and we will try to complete this quickly, because this is a very basic project and the main task or main goal for this course is to get you a complete overview of what are the different processes and how you can complete an end-to-end machine learning project, right? So we okay, so the user interface is like this. On the top you will get your different file menus where you can either interrupt kernel or restart kernel. The kernel is nothing but your Python that is being running this complete notebook. Okay, you can create new files, new launcher, everything from this file menu as well. On the left hand side there is a sidebar. You can see like what are the files in your file explorer in this base directory. So this slash is showing you the base directory here where you have started your Jupyter lab. Okay, these are the kernels that are running currently. So currently on the right hand side we are only running a Python 3 kernel with a blank O showing here, which is showing that this kernel is not doing anything right now. After that, these are the different index. So this is a table of indexes. So here I have created a markdown index with the term import library. So it is showing here. You can quickly go from one index to another by clicking on this, right? So let's come again to the top, and these are the extensions. This is an advanced thing that we don't need right now. Okay, so we can close this sidebar. And in any machine learning project, you first need to import all your libraries. So first check whether you have installed NumPy in your environment, pandas, matplotlib and seaborn. Since we have already installed all of these things, we can just run this. So for running, you can either use this play button, and for stopping a particular cell you can use this stop button, or you can utilize your keyboard shortcuts like shift enter. It will run this cell. So this whole is a complete one cell. You can run this cell and go to the next cell by just pressing shift plus enter. So now it is running, and here you have a kernel status busy. So it is currently importing all of these libraries, and now it has stopped running. So it has successfully ran this block of code without any errors. Okay, and it is showing this is the first execution by using this kernel. The second execution will be this. So what I am doing here is I am trying to print all the current versions of all the libraries that I have just imported. So NumPy will have a different version, pandas will have its own version, right? And below these print statements, I am just setting my fonts for different kinds of visualizations. So these are nothing, just initial print statements. So currently we are using NumPy with the version 2.3.2, pandas with the same version, and matplotlib has its own version 3.10.6, right? So that's how you tell anyone when you are sharing this that these are the current versions that has been used for creating the particular machine learning model. Now the next step is to read the data. So you have a data in your CSV and it is stored here. So this slash is your base directory from where you have ran this Jupyter notebook. From there I have a data underscore diamonds folder. I can show you again. So this is data underscore diamonds, which stores your diamond.csv file, right? To read this file, we need to specify this in this fashion. And after that I am printing the number of rows that are available in this data set. So to run this, I am again pressing shift plus enter, and it is showing 53,940 rows, right? Now this df.info command will tell you the complete information of your rows and columns in the data set, and we are utilizing pandas library here. So we have a column with the name caret, cut, color, clarity, where caret has 53,940 non-null rows. So every row has something in it. There are no missing values currently in the data set. Okay, and the d type is showing you the data type of the caret column. So caret column is numerical, cut, color, clarity are all categorical, and panda shows you a categorical column with the term object. Okay. Similarly, depth, table, price, x, y and z, these all columns are numerical columns because they are either float 64 or int 64. Now we can see various statistics about any of the particular column. So let's say we pick depth column, and we will try to get all the statistics. To get all the statistics, we have a describe function in the pandas data frame. So using the dot operator, we have written this command, and by running this we will get the count of depth, means the number of values that are stored in this column, that is 53,940, same as that of the data set, but the mean of these values is 61, the minimum is 43, and maximum is 79, which I have already told you when we are discussing about linear regression and diamonds data set. Other things that are reported by this describe function is the standard deviation in the data set, the quartiles, that is 25%, 50%, 75%, and all this. So you can change here, like if you want to see another numerical column, like let us say table. So how this data is distributed in the table in this data frame. So now you can see the mean has changed. So this is for this table column, it is something around 57, the minimum value is 43 and maximum is 95, right. Now I have discussed about the outliers in this data set. So this is one way of removing those non required values. Why? Because x, y and z are the dimensions of our data of our diamond, and if we are storing something with 0 x in mm, 0 y in mm or 0 z in mm, then it must have some deformity. That is why, or either missing values, that is why someone has already did pre-processing in the data set and has stored 0 values in those places. So we can safely remove these rows completely where either x, either y or either z is 0, right. So let us first find out how many rows are 0 for x, for y or for z. So these statements will only print the value, the number of counts of rows. So there are 8 rows with x as 0, 7 with y as 0 and 20 with z as 0. Now we can use the data frame drop method to remove these particular rows. So we will remove around 35 rows from the data frame. Now we have removed this because we have ran our code of removing the rows from the data frame. Now let us see what is the distribution of categorical data in our data frame. So for that I have created my own Python function here with the name create bar, and it will take a data frame as an input, column name, the name for the x label, for the y label and for the title. I have also created a short documentation for this Python function, that is this function will create a bar chart, that is the count plot from a data frame column. So what we are trying to do is, we have cut color clarity as object, that is categorical data, and we are trying to get the count plot of these data. So for that I have created a general function here, right. So let us run this function definition first, and now we will utilize this function definition to create the frequency of cuts. So I have just created a bar plot of this categorical column of cuts. So there are around the y axis is showing you the frequency of rows that are reporting the cut in a diamond as ideal. So there are more than 20,000 diamonds with an ideal cut and less than 5,000 with the fair cut, right. So here we can easily visualize the distribution of categorical data set in our data frame. So repeating again, since we have 53 distinct diamonds information in our data set, out of those more than 20,000 have the ideal cut. So this is important. Now next we can see what is the distribution of clarity in the data, that is the diamond clarity type. So this is the complete distribution, and for SI1, that is I think IF was the best clarity diamond. So it is somewhere around 2000 or more diamonds have the best clarity diamonds in our data set. Now all these characteristics will make your price go up or down, right. So that is why we are trying to identify how many diamonds and their characteristics are different in for each diamond. Similarly, color also makes or breaks your diamond buying. So the different kinds of colors with its frequency is shown in this data visualization, right. Now after visualizing all of these categorical data, we have a good amount of information that which kind of categorical data is have how much frequency in your data frame, right. Now you can also write this df.isNull command to check whether there are any null values or not, but we don't need to perform this command. Why? Because when we are writing df.info command here, it is already showing us that there are no null values for each of your columns. If there are any null values, then you can see using this command or df.isNull.sum command, which is written here. Okay. So, this command will print 0 for each column like this. So, there are no null values in the data set. Now, let us try to see the distribution of the diamond pricing. So, how means what is the minimum, what is the maximum, how this pricing of the complete data set is distributed. So, for that I am creating a KDE plot here utilizing the Seaborn library. So, you can see that most of the diamonds in dollar are somewhere around 3000 to 4000, but there are few diamonds that are around $20,000, right. So, this is how your diamond pricing is distributed. Now, let us try to, since we are doing each variable for a different thing. So, we can also create a pair plot which will show you all the permutation combinations of all the features that are available in the data set using this sns.pairplot function. Okay. So, it will take time because since this is a large data set and we are trying to get all the possible combinations. So, now our pair plot is ready, and here you can see that y axis will have features and x axis will also have features. So, all features are presented here with their counterparts. Like let us say on the x axis we have first feature as caret, and it is visualized with z, y, x and price and all the available features. So, every feature has their counterparts reported here. So, caret with caret will be reported with a histogram here. So, you can see here that all the columns with their visualization with their own feature will be reported with an histogram, okay, and with other columns they will be reported with scatter plots. Now, you can see that caret with z has some kind of probable relationship where while increasing caret the z value also increases. Now, z is something in mm. So, this value is increasing with the caret values. Similarly, if you want to see caret with price, so here it is. Now, if you want to show price versus caret, then you can easily see that there is a very strong relationship between the price of a diamond and the values in caret. So, as your caret value increases, the price increases exponentially, right. Similarly, you can see the variation of price with each column in this horizontal axis. So, this second column is depth, then table. So, if you increase the depth of a diamond, your price will first increase, then it will start decreasing after a particular depth, which is somewhere here where my mouse is. Similarly, table has also same kind of distribution, where if you increase the values of table after a limit, the price will start decreasing. So, we can see here that caret is highly correlated with price, and we can utilize these kind of features very beautifully in our linear regression model. So, these kind of pair plots will provide you very beautiful informations regarding each feature and your target variable. Okay. Now, since we are trying to create a linear regression model, and for simplicity we will exclude all the categorical columns today. So, to do that we will only select the d types where we are excluding the object variables, and we will try to describe these like we will get a distribution of all the numerical variables. So, with this command you can see that the caret, depth, table, price, x, y and z, these are only the numerical variables that gets automatically picked up by this command, and we can easily see what is the mean, the standard deviation and the quartiles, right. So next we can also list these as a columns. So these are the same columns. Now let us again see the variations in the price. We have already seen this with the pair plot, but we can easily see with the box plot as well. So this is a very basic box plot with the values of caret, and we can see here that the whiskers of the plot stays somewhere around 2. That is, the most of the data set is in between these whiskers, and after that these are some kind of outliers, right. Similarly, this is how the depth is distributed, and it is very well distributed, that the mean of this data set is somewhere between 60 to 65, that is already reported by our other commands previously. And you can also create these box plots for table, price, and distribution of x. Cut. So these box plots are for categorical data, where we are utilizing the cut as the categorical data, and for each type of cut we are getting a box plot for their associated price. So with an ideal cut in the diamond, the mean of the price could be around $2,500, but it can go more than $17,500 here, right. Similarly, we can do this with clarity and with color as well. So you can see how data is differently distributed for each kind of color. Now, before running your linear regression model, you can also try to find out how the correlation values, means how different features are correlated with each other. So here what I am doing is, I have created a correlation matrix utilizing my data frame with all these numerical values like caret depth table, and then I am showing you only the correlation vector with price. So price with price will be correlated, will be highly correlated, so that is why it is showing as 1, but caret with price is also highly correlated with around 0.92 value. Similarly, x is x, z and y are also highly correlated with price. So these kinds of operations will tell you which type of features and what are the different kind of features that you want to include in your linear regression model. So price is heavily correlated with caret, x, y and z here as shown. Okay. Now we will start with the machine learning process. That is, we will first try to segregate our data into train and test data frame, right. So again we will check what is the overall data set we have created till now after pre-processing. So it is showing that now we have only 53,920 rows in the diamonds data set, and now we are importing our scikit-learn the model selection module, and we will import train test split function, okay, because we need to segregate the data set. So running this command, if you have not installed a scikit-learn library, then this will not work, this command will not work. So first you have to install that library. Secondly, we have included only features like cut, color, clarity and price for this operations, and we have identified price as the target response variable here. So we have identified x and y here. Now utilizing the train test split function and specifying test size as 30. So what we are doing is here is we are creating a 70-30 data set split, and this is just a random number generator. You can write anything here, 108, 42, anything. So it will give us 3 different numpy vectors, that is x train, that means whatever the input features that we have given, the 70% of the input features will be stored in x train, the 30% of the input features will be stored in x text, and similarly 70 and 30 in y train, that is the price and in train and test data set. Okay. So after running this, we have generated our x train, x test, y train and y test. Now we can check what is the shape. So you can use this command to print by utilizing this attribute dot shape from these vectors. So, this is how 70-30 split will look like in this data set. Now, we will directly import our linear regression model from the same scikit-learn library, and we will to create a linear regression model, we will use this class linear regression, and it will create this model and store it in this variable model. Okay. And to fit a model, that is what the training is we just discussed earlier. To train your model, you will utilize this fit function from this class linear regression, and you will give two inputs, the features of your training data and the response variable of your training data, which are stored in xtrain and ytrain. Okay. So, now your model is already trained, and these are the parameters that are that are being reported by scikit-learn library. Now, the next step is, after defining your model and training your model, you need to check how good your model was prepared by this all by conducting all these operations. So, to do that, we will jump into model evaluations, and to conduct model evaluations, we will again look into our scikit-learn library and into the matrix module, and will import functions like mean absolute error, mean squared error, and R square score. So, evaluation is nothing but comparing your actual target price of the diamonds and your predicted price of the diamonds by this model. So, to do that, we will utilize the test features, and we will first predict utilizing this created model, and we will predict utilizing the X text, that is the features, input features from the test data set, and we will create the predicted values for each of these rows. Okay. Now, in ypred, that is, this is an array, right, and these are all the predicted diamond price for each row in your test data set. We need to compare this with the actual values stored in the y test. So, to do that, we will utilize these three functions, mean absolute error, mean squared error, right, and we will give input as y test and y predicted values, these predicted values. So, MAE, MSE and RMSE will store the differences between your predicted values and your actual values, utilizing their respective functions and their calculations. Okay. Now, these are your mean apps. So, the trained model is showing R square value of 0.85, which is not good, but this is your scratch linear regression model you have created. So, we are not targeting creating a best model right now. We have just created and we have just learned about creating a model. So, the current R squared value is 0.85, mean absolute error in dollars is $879. So, on an average, what it is showing is, on an average, your predicted value is different from the actual value of the diamond by this much dollars, right. So, this is not a good model, but today we have learned how to create a basic linear regression model. We will try to get better results in our next classes by learning new things and how to create better models. Thank you.